Hello viewers, welcome to our channel Career Prep. In this video, we'll solve a few miscellaneous problems on the topic linear permutation. Since questions based on this topic are most frequently asked in competitive exams, it makes sense to understand the concept well. Questions on linear permutation are dealt with in this video along with clear explanations to make you understand the topic easily. Before we begin, please subscribe to our channel. Also press the bell icon to get notifications as soon as we post a new video. So let's start. A letter lock consists of 3 rings, each marked with 6 different letters. What is the number of distinct unsuccessful attempts to open the lock at the most? Here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that a letter lock consists of 3 rings. There are 6 different letters in each ring. For each attempt to open the lock, 3 letters have to be taken at a time, 1 letter from each ring. Now since there are 6 different letters in each ring, there can be 6 ways of choosing 1 letter from the first ring, 6 ways of choosing 1 letter from the second ring, and 6 ways of choosing 1 letter from the third ring. So the total number of attempts possible with the 3 rings is 6 multiplied by 6 multiplied by 6, which is 216. Now here we are asked to find the number of distinct unsuccessful attempts to open the lock. Now 216 is the total number of attempts possible to open the lock. Now of these 216 attempts, one of them is a successful attempt. So maximum number of unsuccessful attempts is equal to 216 minus 1, which is 215. So the correct answer is option C, 215. How many different 4-letter words can be formed? The words need not be meaningful using the letters of the word Mediterranean such that the first letter is E and the last letter is R. Here you are given 5 options and you have to find out which of these options is the correct one. The word Mediterranean has 13 letters. Now 4-letter words have to be formed using these letters such that the first letter is E and the last letter is R. Now you have to find 2 more letters from the remaining 11 letters. Now of the remaining 11 letters, there are 2 N's, 2 E's, 2 A's and 1 each of the remaining 5 letters. Now the second and the third positions in the 4-letter words can either have 2 different letters or both the letters can be the same. Now let's look at case 1 when the 2 letters are different. Now here 2 different letters have to be chosen from the 8 available different choices, that is the 5 different letters and N, E and A, making a total of 8 letters. So for the second position, there are 8 letters to choose from. So there are 8 ways of filling the second position. Now since the third letter has to be different from the second letter, now we are left with only 7 letters. So the third position can be filled in 7 ways. So the total number of ways when the 2 letters have to be different is equal to 8 multiplied by 7, which is 56 ways. Now let's look at case 2 when the 2 letters are the same. Now here there are 3 options. They can be either N's or, is, or, yes. So there are three ways. So total number of required words is equal to 56 plus 3, which is 59. So 59 different four-letter words can be formed using the letters of the word Mediterranean such that the first letter is E and the last letter is R. So the correct answer is option A, 59. Given four flags of different colors, how many different signals can be generated if a signal requires the use of two flags, one below the other? Here you are given five options and you have to find out which of these options is the correct one. So it's given that there are four flags and a signal requires the use of two flags, one below the other. So out of a total of four flags, two flags have to be taken at a time. So the required number of signals is equal to number of arrangements of four flags taking two at a time, which is nothing but 4p2. Now according to the permutation formula, we know that 4p2 is equal to 4 factorial divided by 4 minus 2 factorial, which is nothing but 4 factorial divided by 2 factorial. Now 4 factorial is 24 and 2 factorial is 2. So 24 divided by 2 is 12. Now we can find the value of 4p2 using the shortcut method. Here, starting with 4 in the descending order, there has to be a multiplication of two numbers. So 4p2 is equal to 4 multiplied by 3, which is nothing but 12. So 12 different signals can be generated from the four flags of different colors. So the correct answer is option D, 12. A flag is to be designed with 6 horizontal stripes colored blue, red, green or black with no two adjacent stripes being of the same color. How many different designs are possible? Here you are given 5 options and you have to find out which of these options is the correct one. So here a flag has to be designed with 6 horizontal stripes colored blue, red, green or black, and no two adjacent stripes can be of the same color. This means the adjacent stripes have to be of different colors. Now the first stripe can be of any of the four colors. Now since the adjacent stripes cannot be of the same color, the second stripe cannot be of the same color as the first stripe. So the second stripe has only three colors to choose from. So the second stripe has only three options left. Now the third stripe cannot be the same color as the second stripe. Now since one color is used for the second stripe, now the third stripe is left with only the remaining three colors. So the third stripe has three options. Now understand the concept here. Now the first stripe can be any of the four colors, blue, red, green or black. Now supposing the first stripe is blue, then since adjacent stripes cannot be of the same color, the second stripe cannot be blue in color. So the second stripe can be either red, green or black. So there are three options for the second stripe. Now supposing the second stripe is red in color, then the third stripe cannot be red in color since the adjacent stripes cannot be of the same color. So now the third stripe can be any of the remaining three colors, blue, green or black. So the third stripe has three options. Similarly, the fourth stripe, fifth stripe and the sixth stripe also have three options. one color option of the previous stripe is not available. Thus, the number of designs possible is equal to 4 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3 multiplied by 3, which is nothing but 4 multiplied by 3 raised to the power 5, which is 972. So 972 uh, flags 972 designs are possible using the colors blue, red, green or black with no two adjacent stripes being of the same color. So the correct answer is option B, 972. Find the number of different signals that can be generated by arranging at least two flags in order, one below the other, on a vertical staff if 5 different flags are available. So here you are given 5 options and you have to find out which of these options is the correct one. Now it's given that there are 5 different flags available and a signal has to be generated by arranging at least two flags in order, one below the other on a vertical staff. At least two flags means a minimum of two flags. So a signal can have a minimum of two flags, one below the other. So the signal can consist of either two flags or three flags or four flags or five flags. Remember that OR means addition. Now, for a two flag signal, there will be two vacant places, one below the other on the vertical staff in the signal. So the first vertical place can be filled by any of the 5 flags. So the first vacant place can be filled in 5 ways. Now since one flag has already been used to fill the first vacant place, the second vacant place can be filled by any of the remaining 4 flags. So the second vacant place can be filled in 4 ways. So the total number of signals is equal to 5 multiplied by 4, which is 20. Now let's use the formula method. Here, since two flag signals have to be formed, it means that two flags have to be taken at a time out of the 5 available flags. So the number of signals is 5p2. According to the permutation formula, we know that 5p2 is equal to 5 factorial divided by 5 minus 2 factorial. Now, which is nothing but 5 factorial divided by 3 factorial. Now 5 factorial is 120 and 3 factorial is 6. So 120 divided by 6 is 20. Now we can find the value of 5p2 using the shortcut method. That is, starting from 5 in the descending order, there has to be a multiplication of two numbers. So 5 multiplied by 4 is 20. So 20 two flag signals can be formed. Similarly, for a three flag signal, there will be 3 vacant places, one below the other on the vertical staff. Now the first vacant place can be filled using any of the 5 flags available. So the first vacant place can be filled in 5 ways. Now since one flag is used to fill the first vacant place, there will be only 4 flags left now. So the second vacant place can be filled in 4 ways. Similarly, since one flag has been used to fill the first vacant place and one flag has been used to fill the second vacant place, now there are only 3 flags left. So the third vacant place can be filled in 3 ways. So the total number of signals is 5 multiplied by 4 multiplied by 3, which is 60. So 60 3 flag signals can be formed. Now let's use the formula method. Now since 3 flag signals have to be formed, it means that 3 flags have to be taken at a time out of the 5 available flags. So number of signals is 5p3. Now according to the permutation formula, 5p3 is equal to 5 factorial divided by 5 minus 3 factorial, which is nothing but 5 factorial divided by 2 factorial. 5 factorial is 120, 2 factorial is 2. So 120 divided by 2 is 60. So 60 3 flag signals can be formed. Now the value of 5p3 can also be found using the shortcut method. That is, starting from 5 in the descending order, there has to be a multiplication of 3 numbers. So 5p3 means 5 multiplied by 4 multiplied by 3, which is 60. So 63 flag signals can be formed. Continuing in the same way, we find that the number of 4 flag signals is 5 multiplied by 4 multiplied by 3 multiplied by 2, which is 120. Using the formula method, it will be 5p4, which is 5 factorial divided by 5 minus 4 factorial, which is nothing but 5 factorial divided by 1 factorial. 1 factorial is 1. So we are left with 5 factorial, which is 120. Now using the shortcut method, 5p4 is equal to 5 multiplied by 4 multiplied by 3 multiplied by 2, which is 120. So 120 4 flag signals can be generated. And the number of 5 flag signals is equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 120. Using the formula method, it will be 5p5, which is nothing but 5 factorial. 5 factorial is 120. Using the shortcut method, 5p4 is equal to 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is 120. So 120 5 flag signals can be generated. So the required number of signals is equal to 20 plus 60 plus 120 plus 120, which is 320. So 320 different signals can be generated. So the correct answer is option C, 320. In how many ways can the letters of the word judge be arranged so that all the consonants come together? Here you are given 5 options and you have to find out which of these options is the correct one. The word judge has 5 letters, of which 2 letters U, E are vowels and 3 letters J, D, G are consonants. Now group all the consonants in the given word and write the word like this. Now when the consonants J, D, G have to always come together, they can be assumed as a single unit. Now this single unit together with the remaining 2 letters will be counted as 3 letters. Now 3 letters can be arranged in 3 factorial ways, which is nothing but 6 ways. Also, the consonants J, D, G can be arranged among themselves in 3 factorial ways, which is 6 ways. So the required number of arrangements is equal to 6 multiplied by 6, which is 36. So there are 36 ways in which the letters of the word judge can be arranged so that all the consonants come together. The correct answer is option A, 36. In how many of the distinct permutations of the letters in Mississippi do the four I's not come together? Here you are given 5 options and you have to find out which of these options is the correct one. Now to solve this problem, use the formula. The number of arrangements where the four I's do not come together is equal to the total number of arrangements minus the number of arrangements where all the I's occur together. So first let's find out the total number of arrangements. Now there are 11 letters in the given word Mississippi. So the overall factorial is 11 factorial. Also in the word Mississippi, I appears 4 times, S appears 4 times and P appears 2 times. So the repeat factorials are 4 factorial, 4 factorial and 2 factorial. So the total number of arrangements is equal to 11 factorial divided by 4 factorial multiplied by 4 factorial multiplied by 2 factorial. We know that 4 factorial is 24 and 2 factorial is 2. So this can be written as 11 multiplied by 10 multiplied by 9 multiplied by 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial divided by 4 factorial multiplied by 24 multiplied by 2. The 4 factorial of the numerator and the 4 factorial of the denominator cancel out. And on solving this, we get 34,650. So the total number of arrangements is 34,650. Now let's find out the number of arrangements where all the I's occur together. To do this, first group all the I's in the Mississippi, in the word Mississippi, and write the word like this. Now, when all the I's have to always come together, they can be considered as a single unit. Now, this single unit together with the remaining 7 letters will be counted as 8 letters. So, the overall factorial is 8 factorial. Also observe here that S appears 4 times and P appears 2 times. So the repeat factorials are 4 factorial and 2 factorial. So the 8 letters can be arranged in 8 factorial divided by 4 factorial multiplied by 2 factorial ways. Now this can be written as 8 multiplied by 7 multiplied by 6 multiplied by 5 multiplied by 4 factorial divided by 4 factorial multiplied by 2. Now the 4 factorial of the numerator and the 4 factorial of the denominator cancel out, and on solving this we get 840. Also there are 4 I's, which means the overall factorial is 4 factorial and I appears 4 times. This means the repeat factorial is 4 factorial. So the 4 I's can be arranged among themselves in 4 factorial divided by 4 factorial ways, which is nothing but one way. So the required number of ways is equal to 840 multiplied by 1, which is 840. So the number of arrangements where all the I's occur together is 840. Now we have found out that the total number of arrangements is 34,650 and the number of arrangements where all the I's occur together is 840. Substituting these two values in the formula here, we get the total number of permutations where the 4 I's do not come together is equal to 34,650 minus 840, which is 33,810. So there are 33,810 distinct permutations of the letters in the word Mississippi where the 4 I's do not come together. So the correct answer is option D, 33,810. Viewers, please go through this video till you have understood the concept. Please do watch all our videos on solved problems on linear permutations for better understanding. Please do watch our videos on combinations. If you have liked this video, please like, subscribe and share this video. Thank you.